All right, let's classify first. What's the first one? Circle. The first one we said was a circle. This one hopefully is easy. This one, if this was one of the two that you got, this would be your easy, quick points if you know what you're doing. Okay, it's a cosine, so it's on the polar axis. It's got, the A is 2, which means your diameter is 2, and it's negative, so it goes to the left. Let's say you get to the test and you get this question and you freak out and you blank. Then you literally could plug in a point and test it out. I could plug in 0 for theta. I'd get negative 2 cosine of 0. Cosine at 0 is 1, and I get negative 2. So at 0, which is normally over here, I get negative 2, which brings me back to the left. And you can always make sure you know what you're doing, both one simple point on a circle, okay? What's the second one? A lemniscate. So how do you approach a lemniscate? Oh, that's a good sign. What would you do if it was a lemniscate? What else would you look for? You want to know what A is, and the one in there is what? Squared. So A is 3. What does that tell you?
That it goes to the 3.
Goes how far out it goes, right? What else do you want to know for a lemniscate?
You
good. Well, either sine would be to the pi over 2, but it's also because it's a lemniscate, it would be symmetric to the pole. So then how do you find where you go all the way out to 3? You could, but you'd have to do a lot of guess and check. You make R your A, right? Set it equal to that. Then you can find where your loop is. A, well, if you're plugging into R, it's A. If you're replacing R squared, it's A squared. For the second one, we said this was a lemniscate. We said our A squared is 9, which makes A 3. That's as far out as you're going to go. It's not really called a pedal for a lemniscate, but it is a loop, whatever. That length is 3. And it's symmetric to the pole because it's got the R squared. So I take my A, I plug it in for the R. I'd get 3 squared is 9, and I say 9 equals 9 sine 2 theta. Divide both sides by 9, and I get 1 equals sine 2 theta. Before I can get to the theta, I got to get rid of this sine. So where is sine 1? Pi over 2 would equal 2 theta, and then I would divide both sides by 2 or multiply by a half, and I get theta equals pi over 4. Now I know where that loop happens. I go pi over 4, 3, and I make my loop, and then this is in an infinity shape, so I go the other direction, 3, and I make my loop, and that's it. Again, I think these are relatively easy. So if you know what you're doing, it shouldn't be hard. If you don't know what you're doing and you're plugging and checking points, you're gonna waste your test time. All right, then the third one. What is this? This is a limison. Okay, how do I know it's an inner loop? A is 2, B is 3, A over B is 2 over 3, which is less than 1, so it's inner loop. Then what do you do from there?
From there, you add the 2 to get the max.
You want to know the max?
And it's a cosine, so it goes on the x-axis.
And you want to know the min. Good. The cosine, so that the max is going to be on the x-axis. You could set it equal to your max and find if it's on the right or the left.
The min would be 1.
Actually, the min's negative 1. Sorry. The min's negative 1. A minus B. And that goes opposite it. That's where your loop happens. All right, I'll go back and finish that, but I want you to do it. All right, then we get the limison. You are guaranteed a limison. You will either get an inner loop, a cardioid, a dimpled, or a convex. It is happening, folks. Be prepared. The limisons take extra points to get. There's no way to just guess. If you just guess and it's a terrible shape, I will not give you the full credit. You have to have at least the minimum work that we're about to do, which is first identify the type of limison. A is the one that's by itself. B is the one attached. So 2 over 3, again, we would ignore signs if there was a negative there. 2 over 3 is less than 1, which makes it an inner loop. I will throw some pity points in your direction if you can get that it's a limison in an inner loop. You're not getting all the points, but you'll get some, okay? Then you want to find your max. To find your max, you add the A and the B. This would be 5 in this case. And then you want to find your min. You would subtract the A minus B, and you get negative 1. Then I want to find where the max happens. The max happens by finding where R of theta is 5. So 5 equals 2 plus 3 cosine theta. 3 equals 3 cosine theta. Cosine theta equals 1. So where is cosine 1? 0. That tells me, God bless you, 0 is where my 5 is. That's the rounded side of my limison. Then opposite the 0 would be your pi, and that's where your min happens. So if it's pi -1, it actually goes away from pi, and my point is on the opposite side, to the same side as the 0, which makes sense for an inner loop. If it was a cardioid, I would expect that point to be at 0. If it was a dimpled, I would expect it to be at 0. Yeah.
Since it says,
Not necessarily at 0, sorry, just for a cardioid. Sorry.
It says cosine and it's like on the x-axis no matter what. Like, do you have to plug in max?
Well, that's how you know if your rounded side's on the right or the left.
Oh.
Because this could be flipped.
Got it.
Yep.
Okay.
All right, now I need to find points. The minimum I would say you can do is 1 point from the rounded side. So I don't care if you pick pi over 6, pi over 4, or pi over 3, but you need to pick one of them. So I'm going to split the difference and make it the pi over 4, but you did not have to plot pi over 4. And by plotting, I mean plug it in. 2 plus 3 cosine pi over 4. What is the cosine at pi over 4? Square root 2 over 2. And then we said we're going to approximate root 2 to be 1.4. So 2 plus 3 times 1.4 over 2 is 2 plus 4.2 over 2. 2 plus 2.1, which is 4.1. They are not all going to be pretty even numbers, okay? So that would tell me at pi over 4, it's 4.1. So I go to past 4, just a smidge at pi over 4, and I plot a point. Because this is symmetric to the polar axis, which you will also get points thrown at you for, okay? That means it reflects down to the pi over 4 in the 4th quadrant. So 4.1 is also there. Then, that's 5.1. Thank you. 4.1. Okay. Then I would say on the other side, first I would grab the quadrant angle, so whatever's at the top or the bottom or the right or the left if I need it. So this would be pi over 2. Come on, work with me here. I'm going to plug in pi over 2. So 2 plus 3 cosine pi over 2. The cosine at pi over 2 is 0, and that's 2. So at pi over 2, it's 2, and at 3 pi over 2, it would also be 2. And now I would say I just probably need one more point to finish it out. So I'm going to plug in something from the 2nd quadrant. I'm going to split the difference again. So I'm going to plug in 3 pi over 4. And I get 2 plus 3 cosine 3 pi over 4. The cosine at 3 pi over 4 is negative root 2 over 2. So this is 2 minus 2.1, which is negative 0.1. So at 3 pi over 2, I'm literally going just a teeny tiny bit the other direction. I'm in 3 pi over 4. I'm going the other direction, and it would reflect this time up to here. And then I draw my curve. So I would come from my far point out. It's going to loop around on the inside and come back out. It does not have to be perfect, but you have to have all that work if you want the full points.
I thought it was supposed to cross over the pile.
None of the points I got had me cross over. Because it was a negative, it brought it back. So remember, first of all, if you don't know your unit circle angles, you're going to get stuck 700 times. Like, you have to know your unit circle angles and your coordinate points for this and for the conversion of the polar. Like, it's so important. The other thing is you need to know your life will be easier with your approximations of your root 2s and your root 3s. We said root 2 was 1.4. Root 3, we said 1.7. But if you needed to divide that number by 2, you could make it 1.8. It doesn't matter. You're approximating. So you're going to get numbers that are not pretty, and you have to be okay with it. This one requires the most amount of work. There's no ifs, ands, or buts about it. And you're going to get this one. It just could be inner loop, cardioid, convex, or dimpled, okay? And the last one is a rose. What do we know about that rose?
4 petals.
4 petals.
Oh, I thought it was if it was even.
A is 4. If it's even, we double the n.
Okay.
Yep.
Oh, but it's the second one. That was before. Okay.
No, the 4's the length. What else do you know if it's even?
It's the second.
All 3 symmetry. Okay. All right, then came the rows. So the rows, I know it's a rows because it has a number next to theta and it's not squared. If it had that number next to theta but was squared, it's a limnoscape. I know that that number is even, and if it's even, I double it to get the number of petals, which means there's 4 petals. The number on the front is your petal length, which means A is 4. If it is even, it also has all 3 types of symmetry. If it was just cosine, it would be the polar axis. If it was just sine, it would be, and it was odd, sorry, then it would be pi over 2. But if it's got the even number of petals, it's also all 3. Now to find where the first petal is, I set it equal to the petal length. So I set it equal to 4. Divided both sides by 4. I got sine of 2 theta is 1. That tells you 2 theta is pi over 2 because that's where sine is 1. Now if I wanted to find all my petals, I could make it pi over 2 plus 2n pi. And solve it like it's a multiple angle equation. Then I would divide by 2 or multiply by 1/2, and I get theta equals pi over 4. That tells you that at pi over 4, your petal length is 4. Now, because it has symmetry to all 4, that means if I go across the y-axis, I also am at 4. And if I go across the polar axis, I'm also at 4. And then there I can reflect again, and I get all 4. If it was odd, it is not as easy to find. If it was odd, I would do my multiple angle option, which is then divide this by 2 or multiply by 1/2 and a half, and I get theta equals pi over 4 plus n pi. And that tells you it happens at pi over 4 plus 1 pi, which would be 5 pi over 4, and then you found both those, and then you can reflect it. So again, if it's even, because you have all 3 types of symmetry, you really should only have to find 1 petal and you can reflect it. But if it was odd, I would solve it using the multiple angle process to find all the other ones. Otherwise, you're plugging in points. Questions? Okay. Questions on the PDF from last night? So that is just one section of the 4. This is not like you can't walk away from here today. Hopefully that was okay. We can't walk away from here today saying, oh, I got that class kick, I'm good. That's not the case. It is 1/4 of your test, okay? All your parametric stuff that we talked about yesterday is here. Remember, there were 3 types of parametric equations. One where you're graphing it, one where you're eliminating the parameter, and then one where you're bringing it back in. Those are the 3 types you're getting from your parametric. Questions on any of those? All right, then came your polar coordinates. This is where your calculator portion comes from. So those are the ones I added on the bottom, okay? You'd have to be able to convert from polar to rectangular, rectangular to polar using your calculator. That's how you will start the test. There's 2 of those. And then you will have to be able to do it like these without a calculator. And that takes knowing your unit circle coordinate points. Then you'll have to plot it and be able to find additional points. So all that stuff is on your test. Yep. So you're just plugging in. So you're going to get your t, right? You plug your x, you plug your y. Or is this the one that eliminates? Eliminates. So for this one, there was no avoiding the square root or the cube root. So I would do the cube root because then you don't have to do plus and minus. T would equal the cube root of x. And then I'd get y equals 1/2 t, which is the cube root of x, squared. So you can rewrite that as like x to the 2/3, but you don't even need to. Like I would have taken that answer. Yeah.
So it's just find the equation.
Yeah. You won't even need to, those are set, I separated them out. Okay. Yep. Which one?
86.
Yeah. So the, like the A with x equals t or the B with t equals, let's do B because it says t equals 1 minus x and 86y equals 2x to the 3rd plus 5x. So you have to find the one that has the t in it, right? Solve for the other variable. So I'm taking this, I'm solving for x. So I would get t minus 1 equals x, negative x. So negative t plus 1 equals x. And I just, by preference, would flip it, 1 minus t. That then goes into the other equation in place of the x's. So I'd get 2, 1 minus t to the third plus 5, 1 minus t. So I didn't do something you have to cube, but you would have to expand and FOIL that out. Yeah, and then you would have to distribute and combine your like terms. It just wouldn't take that long because you wouldn't have to cube it. You could have to square it maybe, but not cube it.
So you did B first?
I just did B because you'll only get one of them. Huh? I did not. A is just that x equals t. So then it would be y equals 2t to the third plus 5t. That's it. You would just plug t in the place of the x. But remember, the answer for these are both equations. The answers are the x and the y.
So that would be also X equals T.
X equals t. These two would be your answers. Yep. And this one over here, like once that's expanded, x equals 1 minus t would be one of my answers, and then y equals would be the other one.
And then before you leave the 65, I don't get the eliminating part.
So you want to pick which one you want to solve for t. Sometimes one's easier than the other. This time they both end up with fractions, so it really doesn't matter. So let's say I pick the top one. T would be x over 2. And then I would take that and plug it into the other equation in place of the t. So y would equal 4 times x over 2. And y would equal 2x. That eliminates your parameter.
And that's the answer.
That's it. Yeah, and you won't have to graph them. It's not going to be eliminate and graph. It's going to be graph and then eliminate separate. But that would have just been a line. All right, how about, well, we did some of 9-6, but any other ones? I will say this, 127, and it's not going to be on this test, but it does come back. I think it's on your final if you're taking that, where your radius is -5. Like, that's that circle. All the rest are fair game. So what is 131? What type of graph is that? 131 is a circle. Where is it? Top, right, bottom, left. To the right. What is 133? A limicon. What kind of limicon? It's a 5 over 4, which would be dimpled. Okay. What is 135? A limicon and a inner loop because it's less than 1. What is 137? A rose. How many petals? Length of each petal? Good. And what is number 139? Limniscate. Okay. Length of the loop? 5. Yeah. Sure. Yeah.
Would that,
For limniscate? Yeah. Mm-hmm.
wait, but would that be like, is that 5 squared?
So the petal length would be the square root of 5. It would be like a 4.1. You'd approximate it. Yep. But when you find it, you plug it back in, you square it anyway. So it'd be 5 equals 5 sine 2 theta. Sine 2 theta 1. That means 2 theta is at pi over 2, and theta is at pi over 4. So again, here, here. Questions? All right, I have, if you did this, great. I have an extra one I will post for you, for those of you that are ready for it. If you did not do this, you have your work cut out for you this evening. 137's, first of all, look at this question. Every single one of you should be able to identify what type that is. What is it? 137 is a? It's a rose. What's true about it?
It has 4 petals.
4 petals. Petal length is
3.
3. Okay. So, and what kind of symmetry?
All
It's all 3 because it's even. So the first thing I'm going to find is the first petal. So I'm going to set it equal to 3. God bless you. I get cosine 2 theta equals -1. 2 theta would equal pi, because that's where cosine is -1, and theta is pi over 2. So on your polar axis, pi over 2 would have, pi over 2 at the top, sorry, would have -3, which reflects it down here. But because it has all 3 types of symmetry, I know it also goes up. Now, normally, obviously, it's even, so it has to have symmetry to the right and the left. The only way it's going to split the difference is going to be on the other axis. But you have two choices from here. If you want to plug in 0 and see if you're right, then I would plug in 0. -3 cosine 2 times 0. -3 cosine of 0. What's cosine at 0? 1. So this is -3. So at 0, instead of going towards it, I go away from it. -3, which confirms that shape. Go towards it would be my reflection. No, but if it's odd, you're going to have to get some additional information. You're not going to be able to use all three types of symmetry. So if it was odd, let's say from here, I would get pi equals 2 theta. Hello, sir. Plus n pi. Emily's right there. And then divide everything by 2. And I'd get theta equals pi over 2 plus n pi over 2. And this tells me it happens at pi over 2 plus every pi over 2 past that. So pi over 2, and then pi over 2 plus pi over 2, which is pi. And then pi plus pi over 2, which is 3 pi over 2. And then 3 pi over 2 plus pi, which is 2 pi. And if you look at your graph, that's exactly where all these petals are.
Didn't we do something like that last year?
We did multiple angles, and we did it with these. We've done it twice. Yeah. Let's say your question, so we didn't need to do it, but let's say it's odd. Let's say it's r equals 4 cosine 3 theta. Let's practice it, because let's say it's odd. You cannot use all three types of symmetry. So tell me what we know about this rose. It has 3 petals. It has polar axis symmetry, not all 3 types, just polar, and the length is 4. So the first thing I do is plug 4 in. So 4 equals 4 cosine 3 theta. Cosine of 3 theta equals 1. Where's cosine 1? 0. So it would be 3 theta equals 0 plus 2n pi if I want to use the multiple angle trick. You add on the interval. Then I would divide everything by 3. So my theta happens at 0 plus 2n pi over 3, which means it happens at 0. Then it happens at 0 plus, I'm going to make this 1, 2 pi over 3, which is 2 pi over 3. Then it happens at 2 pi over 3 plus 2 pi over 3, which is 4 pi over 3.
Oh, that's not bad.
No, I know. And how many petals do we have? 3. So 1's at 0. Petal length is 4. 1, 2, 3, 4. It's here. 1's at 2 pi, which is here. And 1's at 4 pi over 3, which is here. So if it's odd, I would recommend this method. If you don't use that method, then you'd have to find the first one we would find here, and then we'd be trying to guess and check where the other ones are. Obviously, if a petal there's 3 and 1 goes to the right, I know there has to be 2 over here, but you'd be literally guessing and checking your angles in there to find which one gives you the petal.
So you just go until you reach the amount of petals?
Yeah. Yeah, if I add another 2 pi over 3, I get 6 pi over 3, and I'm back at 2 pi, which is 0. So you could keep adding, but you're just going to duplicate your petals.
So what if it's like 2 positive? Do you have to go like in, so you need to go in the negative direction? Or
They would all be there.
Okay.
Yep.
So there's gonna be 1.
You're getting a limison, and then you're getting one more that will either be a circle, a lemniscate, or a rose.
So 1. Okay.
But that is only 1/4 of your test. Like, we spent all day on this, but that is 1/4 of your test. You still have to review the other stuff. 1. Any questions on 10-1? We need to know midpoint. We need to know distance. We need to know sphere.
How are you going to do the graphs? Is it just going to be like the 3 lines?
Yep. Yeah. So there's 2 types of questions where you're going to get the points. One where you literally have to plot it, which was like the warm up and all that stuff like that we did. You'd come forward, you'd go right, you'd go up, like the warm up from yesterday. And the other is like this. You'd have to be able to understand those words, right? If it's located in the XY plane, I don't even worry about that. 3 units to the right, that's your Y. 5 units behind, that's an X, and that would be negative. And then it doesn't say up or down at all, so the Z would be 0.
No, I didn't get to 1 because I did not
If you want to screenshot the one that's on your warm up, you could. That's the one that's on your test. Yep. The y is to the right. It's a positive y. So right and left is y. Forward and back is x. Up and down is z. So if it's to the right 3 units, that means my y is 3. 5 units behind is 5 units back, so that's an x. And then it doesn't say up or down at all, so it'd be 0. If it's at above or below, then it would be your z.